Alrighty, hi everybody. So today we're going to be talking about the Fundamental Theorem of Calculus Part 2. So I'm kind of going out of order. But before I actually introduce the theorem, let us do a really quick example to demonstrate why the theorem works, and maybe you come to a striking realization, who knows. So here's an integral that I'm sure we all are confident that we could do. So this is the integral from 1 to 2 of 4x cubed dx. So this is just a simple factor, simple polynomial, but here's the formula if you guys forgot. Had written down up here. So the integral of x to some power is equal to x to the n plus 1 over n plus 1, and n can be any number except -1, of course. Alright, so let's do the integral. We add the power, just like you see here. We get 4, divide by 4, and now we cancel, and we come up with x to the 4th as the integral of 4x cubed. So, and we apply the limits from 2 to 1, so we get 2 to the 4th power minus 1 to the 4th power, and that is going to be 15. So that's our final answer. So that was a definite integral. And now I will show you the Fundamental Theorem of Calculus Part 2, and maybe you'll realize some similarities. So here it is. So let's read what it says, and then we'll explain what it actually means in English. So if f of x is continuous on an interval a to b, so maybe something like this, it's continuous from a to b, and big F prime, so the derivative of big F of x is equal to f of x, then this is the fundamental conclusion, that the integral from a to b of little f of x dx is equal to big F evaluated at b and a, and they're different, so the integral from a to b of f of x dx is equal to big F of b minus big F of a. So let's look at the work that we just did, and we're going to see some differences and a lot of similarities. So let me circle in red. So here's f of x. As you can see, f of x is given as 4x cubed. Okay? 4x cubed. And so we do the integration, and we come up with the integral as being x to the 4th, which is also right here. So here's f of x, and here is big F of x. So it's important to recognize what big F of x is, what little f. So big F of x is just, it's the actual integral of f of x. And now, since we're going from a to b as a definite integral, we're going to plug in b, which would be 2, minus f, big F, which is x to the 4th, of a, which is 1. And that is actually reflected up here. So as you can see, the second fundamental theorem, the Fundamental Theorem of Calculus Part 2, you've actually been doing it the entire time. You just haven't realized it. So you use Part 2 to do the following. Use Part 2, evaluate integrals. And that's pretty much it. So as usual, like, comment, subscribe. Let me know if anything didn't make sense, or maybe you would like another example. I could always make a part 3 to this part 2, or part 1 to this part 2. But anyways, good luck. See ya. Bye.